Hello everyone, welcome back to Techmine Guru. I am your coach Supratim and today we are continuing our DSA complete journey. Now we are going to enter into our arrays part 3. Today we aren't just writing loops, we are learning the power of pre-computation. आज हम simple data collections को powerful बनाएंगे. If you want to crack those hard coding interview problems where time limits are tight, this video is for you. So here we will learn the intuition of a prefix sum, basically from the cricket scores. Then we will master how to solve range sum query. And then finally, using that range sum query technique, we will see how to solve a boss level problem, which is special index. So let's see. Given n elements and q queries, for each query, calculate sum of all elements from L to R, considering the fact that array given is 0-bit indexed. Now, given the array -3, 6, 2, 8, 4, 5, 2, 8, -9, 3, 1. First query, suppose L is 4 and R is 8. So 4 to 8, we have to find the range sum. So what will be the value? 2 plus 8 minus 9 plus 3. The sum will be 9, right? Similarly, if L is 3 and R is 7, what will be the range sum? 4 plus 5 plus 2 plus 8 and minus 9, right? Because now we are asking from 3 to 7. So we have to add 4, 5, 2, 8 and minus 9. And similarly, if query is 3 and L is 1, R is 3, we will count 6, 2 and 4. And similarly, if L and R are same, we will just take the only value. So let's start with an intuition, something which we all understand, cricket. Look at this table. You have the overs on the top and cumulative scores below. Now imagine I ask you a simple query. How many runs were scored specifically in the 7th over? Will you go back and recount every single ball bowled from the first over? No, right? You just look at the scoreboard. You see the score at the end of over 7, which is 65, and the score at the end of the over 6, which was 59. So you simply do the math, 65 minus 49, which is equal to 16. So you didn't recount, right? You just used a prefix sum technique. So this is the core concept we are going to master today. So let's see, if I ask you what is the run scored from 6th to 10th over. So score of 10th over is 97. Score of 5th over is 31, right? So if we find the difference, then we can say that the score from 6th to 10th over is 66. Similarly, if I ask you what is the run scored in just 10th over, which is 97 minus 88, 9 runs, right? Similarly, for the 3rd to 6th over, what is the score? You will have the score of the 6th over, which is 49, and the score of the 2nd over, which was 8, because 3rd over started from here. So 49 minus 8 is 41. And similarly, you will get for 4 to 9th over also. So let's understand that with the other example as well. So you have given an array representing the daily profit and loss from a particular stock over a period of time. So you have to write a function that calculates a total profit or loss on a given range. This is exactly similar to our original problem statement, right? So on day 0, the price of the stock was -5. On day 1, it was 10. And day 2, it was 20. And similarly, till day 9, it was -10. So if I ask you what is the total profit loss from day 1 to day 4, so what will be your answer? So 10 plus 20 plus 40 plus 50, which is equal to 120. Similarly, if I ask you what is the total profit or loss from day 0 to day 1, so it will be -5 plus 10, which is equal to 5. There is a catch in it. The constant for this question are very high. Suppose it is given that n is equal to 1 lakh elements and q is equal to 1 lakh queries, and the time limit is 1 second. So let's first think about the brute force approach, which is, I think, the obvious path is to solve any question step by step. So for each query, we will run a loop from L to R and we will calculate the sum. So here we are running a query from 0 to q minus 1, and in the q, you have been given a left index and a right index value. So let's keep it in L and R. We will take a sum equal to 0 and we will run an inner loop of j from L to R. to calculate the sum. But let's analyze the time complexity. If we have a loop inside a loop, one for the queries and one for the sum, that is order of q into n. Mathematically, it will be 10 to the power 5 into 10 to the power 5, which is equal to 10 to the power 10. And it is breaking our golden rule that anything can't be more than 10 to the power 8. So this will definitely give a TLE. So here comes the superpower, the prefix sum array. Instead of calculating the sum every time, we create a new array called PF, which is prefix sum array. In this array, PF of I will store the sum of all elements from index 0 till that index I. So let's understand how to create the prefix sum array. Let's take the first value as prefix sum of 0. Now we will run a loop from 1 to n minus 1, and we will keep adding the previous prefix sum value with the current element. So suppose your array look like this, original array A, 2, 5, minus 1, 7 and 1. So prefix sum of 0 will be 2 only, since we are initializing prefix sum of 0 as A of 0. Now prefix sum of 1 will be prefix sum of 0 plus this element 5. So 2 plus 5 will be 7. Similarly, prefix sum of 2 will be prefix sum of 1 plus original array element of that index, which is minus 1, 7 minus 1 is 6. Similarly, prefix sum of 3 will be equal to prefix sum of 2 plus element 3, which is 7. So 6 plus 7 equal to 13. And like this, we will get 13 plus 1 is equal to 14. So let's come back to our original question now. So our original question said that we have an array and we have a second query array where certain indexes are given, right? That was the original problem, right? So now how to apply this range sum query problem? So if you have to find sum of 0 to r, what will be equal to? So sum of 0 to r will be equal to sum of 0 to l minus 1 and sum of l to r. But now we have to calculate the sum from l to r. So what will be the sum from l to r? It will be this block minus this gray block. So sum of l to r will be equal to sum of 0 to r minus sum of 0 to l minus 1. So using prefix sum formula, what we learned, that sum of l to r will be equal to prefix sum of r minus prefix sum of l minus 1, right? Suppose we have to find sum of 0 to r, it will be prefix sum of r, and if I have to find prefix sum from 0 to l minus 1, it will be prefix sum of l minus 1. So let's put this above formula in our final optimal solution to get the result. So in this, we have calculated our prefix sum array first. In this, we ran a loop from I equal to 1 to n minus 1, where prefix of I is equal to prefix of its previous element plus a of I. And then we will run a separate loop from 0 to q minus 1 till the range of the query. And so this L of I will give you the left range, and this R of I will be given in the question as a right range. So using the simple formula, we can get the sum in each step for every query, for every range query. But there is a catch in it. What if L is equal to 0? When L is equal to 0, if you see, if L is equal to 0, then there is nothing in this gray side. So that's why that time everything can be calculated by prefix sum of R. We have to handle this case. If L is equal to 0, sum will be equal to PF of R. So now our time complexity reduces from O of n into Q to O of n plus Q. And since we have taken prefix sum as an extra array, our space complexity will be O of n. Now let's take a level up. So now we have even indexed element sum. So given an array of size n and q queries, for every query, find sum of all even indexed elements from L to R. So suppose the array is 2, 3, 1, 6, 4, 5, and first query says that the L is 1 and R is 3, L is 1 and R is 3. So how many even index elements are there? Only A of 2, right? Which will be equal to 1. Suppose if I give you L is equal to 2 and R is equal to 5, L is equal to 2 and R is equal to 5, how many even index elements are there? It will be A of 2 plus A of 4, which will be 1 plus 4 equal to 5. And similarly, if I give you L as 0 and R as 4, then how many even elements are there? A of 0, A of 2 and A of 4, which will be 2 plus 1 plus 4 equal to 7. And similarly, if L and R is equal, lying in the odd index, then 0 will be our answer. So can we modify our previous prefix sum for this even index? Yes, definitely. Let's see how. So the logic is, if index I is even, then we can add the current value. If index I is odd, we have to copy the previous value. So creation of a prefix array question code will change. So I mod 2 is equal to 0. Prefix of I will be, so if I is even, then our prefix of I will be equal to prefix of I minus 1 plus A of I. And if I is odd, then prefix sum even of I will be equal to prefix of I minus 1. So in this odd case, we will copy the previous value. So now our same optimized code will become like this. This is the same code which has been brought from this place. So what if we need prefix sum of odd index elements? Nothing we have to do in this. Just simply we have to change the condition. If I mod 2 is equal to 1, which tells us that index is a odd index or not. If it is an odd index, we will add the current index in the previous prefix array index, and if it is a even index, then we will just copy the previous value. So let's understand that how we can apply the following concept in a very unique question, which is a special indices count question. So now you are ready for the boss level, the special index question. The problem asks us to count the number of indices where if we remove that index, the sum of even index equals the sum of odd index. So let's understand the question once again. Given an array of size n, count the number of special indices in the array. By definition, a special index is 1 after removing which sum of all even index element will be equal to sum of all odd index element. So if you try to brute force this solution, it will definitely give you a TLE, because you have to run a loop where you have to remove an element and recalculate sum every time. So let's take an example to understand the problem. If we delete index 0, what will be the remaining array? 3, 2, 7, 6 and minus 2. What will be the even index sum? 3 plus 7 plus minus 2, which is equal to 8. And what will be the odd index after removing index 0? It will be 2 and 6, right? So the sum of even index element and sum of odd index element is same. So 0 is a special index. Now let's see for if we delete index I equal to 1. So if index I equal to 1, then what will be our array? 4, 2, since we are deleting this, 4, 2, 7, 6 and minus 2. So what will be the sum of even index? 4, 7 and minus 2, whose sum will come as 9. And what will be the odd index? 2 and 6, whose sum will be the 8. So these two sums are not similar. So this is not a special index. And the question says we have to count such indices, that how many special indices are there in the problem. So let's analyze this problem. So let's look at this diagram, which tells us about the parity flip. So when we remove an index I, everything on the left side is unaffected and stays the same. But look at the right side. Every element shifts one step to the left. This means on the right side, old odd indices becomes new even indices, and old even indices becomes the new odd indices. So to solve this, we need two prefix arrays, prefix even array and prefix odd array. So now the formula becomes a mix of both. New even sum will be equal to sum of evens on the left plus sum of odds on the right, and new odd sum is equal to sum of odds on the left plus sum of evens on the right. Since we are removing the index, odds will become even and evens will become odd. So sum of even index after removing the ith element will be equal to pf of e from 0 to I minus 1, because we are calculating the sum of even, plus since we are removing the ith, all even elements after that ith element will become odd now. So we will add that part pf of o from I plus 1 to n minus 1. Similarly, sum of odd index element after removing ith index will be sum of odd is equal to prefix sum of odd array from 0 to I minus 1, just as we saw the same. And since after removing the ith element, from I plus 1th element, every odd element will convert as an even element. So we have to add prefix sum of even array from I plus 1 to n minus 1. So just we are flipping after the ith index. So let's use the above two formulas in our code. So in this part, we have generally tried to create the prefix sum array. So prefix even sum of 0, we have initialized it with a of 0, and prefix odd sum of 0, we have initialized it with 0. Since array index starts from 0, so that is why prefix odd sum of 0th element will always 0. Now, using the formula which we have learned earlier, if I mod 2 is equal to 0, that means index is even, then prefix even sum of I will be prefix even sum of I minus 1 plus a of I. And if I is odd, then prefix even sum will copy the previous value. Similarly, when I was even, prefix odd sum will take the previous value, and when I is odd, prefix odd sum will add a of I to the previous prefix odd sum of I minus 1. So this is how we are calculating the prefix sum array. Once we have the prefix sum array, we will apply the above formula, which we have learned here, right? This formula, how to count the special indices. So in this, since we know from our previous example, when left index is 0, that means when I is 0, we just have to ignore the left value and we just have to focus the right value. And for both, we have to do the same. So when I is equal to 0, for calculating the sum of even number, we don't have a contribution of this part, we just have a contribution of this part. So how to get prefix odd sum from I plus 1 to n minus 1? It will be prefix odd sum from n minus 1 minus prefix odd sum of I. Similarly, sum of odd elements will be prefix even sum from I plus 1 to n minus 1, whose formula will be prefix even sum of n minus 1 minus prefix even sum of I. And when I will be anything other than the 0, then we have to apply the complete formula. Then sum of even element will be prefix even sum from 0 to I minus 1, prefix even sum of I minus 1 plus prefix odd sum from I plus 1 to n minus 1. So by applying the above formula, we will get prefix odd sum of n minus 1 minus prefix odd sum of I. And similarly, for sum of odd elements, we will have prefix odd sum from 0 to I minus 1, which will be prefix odd sum of I minus 1 plus prefix even sum from I plus 1 to n minus 1, which will be prefix even sum of n minus 1 minus prefix even sum of I. So from here, we will get on each step what are sum of even index till that index and what are sum of odd index elements till that index. And if both are similar, we will increase the count. And the total number of indices after running this loop give us the count of special indices. So again, this problem, if you see, has been broken into two separate loops. So the time complexity will be O of n plus q. And since we are taking two arrays, so the space complexity will be O of n plus O of n, which will be equal to O of 2n, which will be again O of n. So this is a famous LeetCode problem statement, ways to make a fair array. You can try that into LeetCode. I have given you the link as well. So today we have acquired a serious toolkit. Today we learned prefix sums to solve range queries in O1, the formula of PF of R minus PF of L minus 1, how to use conditional logic to copy or add values, and how to recognize a pattern. Just that in last example, we understood about parity flip pattern. So always remember guys, hard problems are just simple patterns hidden behind constraints. So we are just getting started. Next lecture, we will tackle carry forward and sub array techniques. If you found value in this, make sure to subscribe to Techmine Guru. This is Supratin signing off for today. Keep coding, keep learning, keep optimizing. See you in the next video.